In this video, we are going to look at support vector machines. Now, support vector machines, as the name suggests, consist of support and vectors. What are support vectors? Now, support vectors are these lines or vectors. Vector means something that has a direction and a magnitude from physics class 8, class 9th. So this vector, which is on your screen called optimal hyperplane, on the right of your screen is that straight line. This is the support vector that separates two. And the term support comes from these dots that lies here on these gaps, on these margin, because they makes this line strong, because if they are here, this is here, anything on the right and on the left of these things should be belonging to the red circles. Now we generally do a support vector machine on Iris dataset. This is from the scikit library, and this is one of the most common examples that is used. So we have sepal length and petal length, and we have 0, 1, 2, and these are the two examples of support vector machine. Both of the figures are more or less the same stuff. Now sometimes the vector, which is a straight line and a direction, could not be drawn for an example of input space that is given to us, so we transform it. And we get a feature space where we can then separate them when they are separated. So we do various transformation. We'll see some transformation. So one is the linear transformation, support vector machine with linear kernel, linear support vector machine with radical bias function, support vector machine with polynomial degree 3. Polynomial means x, x square and x cube whenever you see that word. And radial function, let's see what it is. Now suppose if I give you a problem where I would say that these are these hollow circles and the square bracket filled up with dark, these are the two things, and you want to draw support vectors. So you can transform this using something called radial transform, in which you would convert all of these things into a coordinates which is radius and angle, and you're going to say that everything that has a radius from origin, which means you take the origin and draw this point, everything has the distance which is less than a particular distance, you map it down. So that's a linear transformation based on radius. Since you use the radius from the origin, it's called radial transform. And once you do that, they get separated, and then you can draw a hyperline. So many transformation help us to convert a problem that otherwise is hard to convert. Let's look at one of the example and the terms again. So the line that separates them is called support vector machine hyperplane. The margin of width is how much width they are. Higher the margin, better it is, and the more lines on the margin, more these points on the margin, the better our classification becomes. Okay, this is a non-linear transformation to understand. If you see, if you want to separate square bracket and these circles, then we have to draw this parabola. If you remember the equation of parabola from high school, it was y is equal to x square. So whatever is or in this case, whatever the value of x, y is always positive. So y is equal to x square. At all these values, y will keep on increasing, y will never be negative. So that's a polynomial example. So we draw this line, straight line, and we do a polynomial transform. If you remember the transformation, the radial transform is based on radius, like these hollow circles. We'll take the radius and draw a new dimension, or we'll transform it based on radius. This one is based on polynomial, which means that y is equal to x square, because this line is like a hyperbola, and dotted line was wrong, but when we do a transform, polynomial transform, then it becomes correct. So once we separate them, then we can draw planes. Another example of r square. On the right, if we want to project this in a 3 dimension based on the radius, when we do that, we get something like this, because all of these radius are like less than this circle if we take it from origin. So I'm revising everything quickly. We have input space, feature space, petal length. We have to do transformation if you want to draw the support vector again. The transformation common are linear, RBF and polynomial, and we see RBF the radius based and the polynomial with the parabola equation.